Hi, this is Rafiul from University of Houston. Today I am going to present my work identifying autonomic nervous system activation from electrodermal activity. Here I used a probabilistic physiological prior-based sparse deconvolution scheme. Neuropsychiatric disorders are considered as 21st century's epidemic and one of the major cause of death. We know that electrodermal activity are modulated by different emotional events. Now, can we use EDA to obtain autonomic nervous system activation so that we can track our neuropsychiatric disorders so that we can come up with appropriate effective interventions? The goal of the study is to utilize EDA to infer sparse brain or ANS activation along with the physiological system parameters. Here we address the existing challenges with current deconvolution schemes. We model EDA as summation of two components, phasic component and the tonic component. The first varying component is called the phasic component, which can be modeled as a convolved result of SNS activity. So brain activity is convolved with a system response H theta. On the other hand, the tonic component is considered as the convolution between a smooth cubic spline basis function and some cubic spline coefficient signal. We obtain the discretized model as well as we obtain the optimization formulation. In the optimization formulation, we considered physiological priors, the sparsity prior on the brain signal U and the smoothness priors on the Q, the tonic component coefficients, and also the Gaussian prior on the physiological system parameters. We utilize coordinate descent approach to obtain all the unknowns. Here we also implemented the generalized cost validation or the GCV approach to obtain the hyperparameters. We show our algorithm's ability to discriminate between event-related and non-event related responses on auditory stimulation dataset. We also compared our algorithm against all the previous approaches, and we show our algorithm is outperforming in terms of identifying the ANS activation and discarding the noise. In future, we plan to extend the approach to multi-channel recording with convex optimization formulation. One of the future goals is to achieve fast implementation for wearable devices in cognitive stress tracking. This work has been supported by NSF grant. Thank you very much for listening to the presentation. If you have any question, please reach out to us. Thank you very much.